Okay, so we're talking about linear patterns today. We're talking about slope, rate of change, and first differences. Some things we did last week and some things are new. I'm going to try to speak a little faster here so the video is not so long. And hopefully if you don't understand something, you just pause it and go back. So here we have a linear pattern. So we have a position number. So this would be position number 1, 2, and 3. And we're going to think about what number of squares do we have in these position numbers. So you can fill in the table here. So in the first one, 1, 2, 3, 4, 5. 5 squares. And then we can see that those 5 are still there, and we're just adding 1, 2, 3, 4. So that would be 9. And then the same ones from the position number 2 are there, and we're adding 1, 2, 3, 4. So we're adding 4 every time. So if we had position 4, we would be adding another 4. Or position 5, I'd add another 5. And then we're going to figure out how to get to position number 100 in a second. So, first differences. We did this last week. It's what is it going up by? We know it's going up by 4. So if I did 9, the second one, minus the first one, 9 minus 5, I get 4. Right? 13 minus 9, also 4. So I'm always going to get 4 because that's what it's going up by. That's the first difference. Now let's take that and put it on the graph. So I have a coordinate here, 1, 5. So on my graph, I go to 1, 5. Right. Go along the x-axis to 1, go to the y-axis to 5, and there's my first point. And then I keep going. I have 2, 9, 3, 13, 4, 17, 5, 21. Oh, wrong one. 5, 21. Okay, and if I were to pretend there was a position 0, we don't have a position 0, let's just pretend we did. If going this way, I'm adding 4. Going backwards, I would subtract 4. So by subtracting 4, I'd end up with just the square that was in the middle. So I'd have 1. In position 0, I'd have 1. And we don't have it in our table, but let's pretend on our graph here, if I went to position 0, which is here, I'd have 1 square. So let's connect that. Oh, not bad. Okay, it's a line with an arrow at the end because it's going to increase. It's going to go forever. And the question now is saying, using the graph, how many squares would there be in position 6? So my graph doesn't go there quite. But if I extended the graph, I kept it going, to look like that, then I go to position 6. I say, all right, I go up. That's where I would hit the line. If I go all the way across, well, that means I'd have 24. According to my graph, I'd have 24 squares. Okay, it's something that's called extrapolation. We'll talk more about that later, but actually you would have researched it last week. It's extrapolation. It's past the last point that I know, or the last point that's in my table. What's the pattern rule? So in words, what's happening here? We're going up by 4, so we're adding 4 every time. And what did we start with? Well, we started with position 1 and had 5, but if we went back, position 0 had 1. So what we want to do is we want to think about what was in position 0. Even though we don't have it, we want to think about what was there. So what's the pattern rule? We're increasing by 4 every position number. For every position, we increase by 4. So the next questions are asking, what's the multiplier? What's the constant? So if we go back up here, I know I'm increasing by 4. I'm adding 4 every time. But if I think about what the number of squares is and the position number, say, well, how are they related? How are the position numbers, or the number of squares, related to the position number? Well, I know it's increasing by 4, so let's think about that 4. 1 times 4, so 4 times 1 is 4, but that's not quite the number of squares. I'd have to add 1. So 4 times 1 is 4, plus 1 is 5. 4 times the position number 2 is 8, but again, not quite 9, so 4 times 2 is 8. If I add 1, I get 9. So it looks like it's the first difference, the increase, times the position number, plus 1, which gets us the number of squares. So 4 times position number plus 1. So what's the multiplier? The multiplier is the thing we're multiplying, right? The number, the 4. So we're multiplying the position number by 4, so that's the multiplier. And what's the constant? The constant is the thing that stays the same. If I go back up to our pattern here, that square in the middle was always there. We just kept adding to that. So that's the constant, the 1. The thing that we're adding is our constant, so 1. What's the algebraic equation? So when you think about the algebraic equation, what you wanted to get is the multiplier times position number plus the constant. Okay, and that's what you would have done in elementary school. Now we're just going to change the words a little bit, but it's the same thing. So multiplier times the position number plus constant. So in this case, our multiplier is 4. Our position number, say n, plus 1. So now if we want to figure out what it would be in the 100th position, I would say 4 times 100 plus 1. So 401. So go back to your table and say 401. So we got a new example here, and it's going to be very similar. I'm just going to use different terms afterwards. So Penny got $1,000 from selling her sneaker collection. She decided to put it in her piggy bank, and each week she spends $135. So after 1 week, right? So she has the $1,000, and then 1 week later, she's spent $135. So she no longer has $135. She has $865. And every week after that, she's subtracting $135. She's losing $135. So 730, 595, 463.25. Pretty sure that's right. And if we look at our first differences, we know what the first differences are based on the question. It says she's spending 135, so that's what it's changing by. But we can't just put 135, because if I actually calculate my first differences, So subtract the second one from the first one. I get negative 135. So you have to be careful of that. Okay, it's not just what it's changing by, it's going to be positive or negative. So in this case, since it's going down, it's negative. So our first differences are negative 135. So we're going to graph this now. Remember that our coordinates come from here, 865. So 865, this goes off the graph, so we'll just estimate 730, about there, 595, close to 600, 460, and 325. Okay. So now we're going to draw our line of best fit. So we want to go through as many points as possible. In this case, it's not going to be too difficult since it's fairly straight. And we're going to ignore this part down here, because she won't have any money left after 100 weeks. So what's the multiplier? The multiplier is whatever the first differences are, whatever it's going down by, or up by, in this case down. So the rate of change, or the multiplier, so we're going to call it the rate of change from now on. The rate of change is negative 135. And what's the constant, or the initial value? I think it's easier if we think about it this way. What's the initial value? What do we start with? So at 0 weeks, she would have had the $1,000. So now when we're thinking of the equation, before I said the multiplier times the position number plus the constant. So now we're just going to change the terms here. We're going to say that rate of change times the position number, or whatever the thing is that we're talking about. But I'm going to say x. So the rate of change times x plus, the initial value. So y is equal to the rate of change times x, that's what the brackets are for, plus the initial value. So in this specific case, our rate of change is negative 135 times x, because we don't know what x is. It's the number of weeks that have gone by, plus the initial value, which was 1,000. Okay, so we have some practice questions down here that you can go over. I will have the solutions on the website, but please try to do them on your own.